So, what is programming and why do we need program? Programming is step-by-step instructions that can be executed by a computer to perform some specific task. For example, solving a mathematical problem or any other type of problems. In order to understand step by step, you can consider this example. Let's say you want a baby to write something on the paper. So you told the baby that, okay, get a paper and then scribble on the paper. So what do you think what will happen? The baby does not have any idea that how to write on the paper, and you did not mention anything about the pen. So the baby is lost. So in order to make the baby to successfully write on the paper, you have to be as thorough as possible about your instruction. You have to specifically mention that, okay, get a paper, then get a pen, and finally start scribbling on the paper. So whenever you will write a program, always consider your computer as a baby and do not miss any of the steps. So why do we need programming? In one word, we are living in the world of programming. Take any example, any technological example from your life, and in the back end, there is some sort of programming. For example, programming can be used to solve some problem quickly. You can automate some repetitive work. You can also do some accurate data analysis by programming. In fact, in today's world, programmings are doing lots of marvelous things. For example, special effects in movie, self-driving car, online shopping, robots. There are lots of examples. And if you are interested how these things are working, so in the fundamental level, you need to learn about programming. Now, when we are talking about the step-by-step instruction to solve a problem, we call it an algorithm. In this slide, you can see the characteristics of an algorithm. So whenever we are talking about step-by-step, there are some characteristics. The first one is input and output. Whenever you will be writing a program or whenever you will try to solve a program, first you have to decide what is an input and what is an output. What is the output expected? For example, let's say you want to solve some mathematical problem. And if you do not have any type of number in your hand as your input, can you do anything? No, right? So that's the same thing on algorithm. The next one is definiteness. Definiteness means each step of an algorithm must be precisely defined. The actions to be carried out must be rigorously and unambiguously specified for each case. For example, let's say you are solving some mathematical problem, and in some step you are not very sure that whether you want to do plus, I mean a summation, or a multiplication, or a division. So this type of ambiguity should not be there when you will write down the algorithm. The next step is finiteness. Finiteness means an algorithm must always terminate after a finite number of steps. Means, let's say you start solving a mathematical problem and in the entire year you could not solve the problem. You started from January 1 and in the December 31 this year, next year December 31, next of next year December 31, you could not solve the problem. So that should not happen in any type of problem solving or algorithm. And finally, the effectiveness. Effectiveness means it must be possible to perform each step of the algorithm correctly in a finite amount of time. Again, the same thing. Your problem, you should solve the problem in some way so that it can be finished at a finite amount of time. Otherwise, the solution does not make any sense.